This is Shuttle Launch Control at T-minus 4 hours, 4 minutes, and 35 seconds and counting. Launch teams are not working any issues right now that would prevent us from launching on time at 4:50 p.m. Eastern. Currently, forecasters are calling for a 90% chance of good weather for this afternoon's launch of Space Shuttle Discovery on its STS-133 mission to the International Space Station. Tanking process, filling Shuttle Discovery's external tank with about 535,000 gallons of liquid oxygen and liquid hydrogen. That process began on time at 7:25 a.m. Eastern. Liquid oxygen began its fast fill process at 8:15 a.m. and then liquid hydrogen side began its fast fill process at 8:16 a.m. So all tanking operations are going on schedule or even slightly ahead of schedule with no issues, including any issues related to the problem that caused us to scrub our first launch attempt for Discovery back in November. And that is related to the ground umbilical carrier plate, or GUP, a hydrogen gas leak back on November 5th at that particular piece of equipment. Did cause the scrub of Discovery that day. So of course the attention has been focused on the GUP and its associated hardware. What you're looking at is what's known as the beanie cap at the very top of the external tank. But the GUP itself, located a little further down on the external tank, has been the focus of the attention this morning, and again, no issues, no hydrogen gas leaks have been seen this morning. But let's take a little closer look at the GUP, what it does to help launch a space shuttle.
A space shuttle ready to launch has numerous connections to the launch pad that require careful attention to assure a safe liftoff. The ground umbilical carrier plate, called the GUP, is one of those connections. The GUP is at the end of the gaseous hydrogen vent arm on the fixed service structure. It attaches to the shuttle's orange external tank. The plate holds a large diameter pipe that collects excess hydrogen gas from the tank as it's being filled with liquid hydrogen. The venting system funnels it to a larger pipe that takes it down the fixed service structure and out to a flare stack that burns the excess hydrogen off safely. At liftoff, the GUP retracts away from the tank, cutting off the connection. The vent arm pulls back to the tower, safely away from the shuttle as it climbs straight up. Because the GUP's connection to the tank is so important, it has sensors in place to watch for hydrogen leaking. Launch controllers track the readings from those sensors closely, and when readings are outside the limits, the countdown is halted. After the external tank is drained of its liquid hydrogen and liquid oxygen and cleared of excess hydrogen, technicians can go out and make any repairs or modifications necessary to fix the leak.
And back here live at Launch Pad 39A, Space Shuttle Discovery poised for its STS-133 mission to the International Space Station, which is orbiting 220 miles above Earth right now, and about 10 kilometers away from the space station right now is the European Space Agency's automated transfer vehicle, the Johannes Kepler. That cargo spacecraft is on track to dock with the International Space Station in less than 90 minutes. And we'll be going live to NASA's Johnson Space Center in Houston for docking coverage of the ATV-2 at 10:15 a.m. Eastern. And we'll continue that coverage live on NASA's public channel until the ATV-2 is safely docked and latches are locked on board the International Space Station, which should be about 11 a.m. Eastern. And back here at the Kennedy Space Center, the launch team is not working any issue right now that would prevent us from launching on time at 4:50 p.m. Eastern at T-minus 4 hours and 5 seconds and counting. This is Shuttle Launch Control. This is Shuttle Launch Control at T-minus 3 hours, 54 minutes, and 45 seconds and counting. Launch teams are not working any issues right now that would prevent us from launching on time at 4:50 p.m. Eastern. Currently, forecasters are calling for a 90% chance of good weather for this afternoon's launch of Space Shuttle Discovery on its STS-133 mission to the International Space Station. We are currently 2/3 complete with the process known as tanking, a 3-hour process of filling Discovery's external tank with about 535,000 gallons of liquid oxygen and liquid hydrogen. That process began on time at 7:25 a.m. Eastern. We then went into liquid oxygen fast fill at 8:15 a.m. And just a couple minutes ago, at 9:26 a.m. Eastern, we went into what's known as liquid hydrogen topping, which means the liquid hydrogen side of the external tank, the full bottom half of the tank, which is the liquid hydrogen side, is 98% filled. Engineers slow the flow of the propellant down from the fast fill. It's called topping until the tank is filled to 100%. But because the tank is obviously warmer than the super cold propellants, specifically liquid hydrogen being minus 423 degrees Fahrenheit, some of that propellant essentially burns off or boils off, and it must be continually added to keep it at 100% level. Get to a point where it's called stable replenish, where engineers have control of the propellant entering the tank and keeping that level at 100%. So as the tank cools, the fluid becomes denser. By continuing to add propellant, it packs it in or squeezes more propellant into the tank. Once the tank is filled up with liquid hydrogen, engineers terminate the replenish phase, and the tank and propellants are then configured for launch. So we are currently in the liquid hydrogen topping, which began at 9:26 a.m. About 15 minutes ahead of the schedule. So all tanking operations have been either on time or slightly ahead of schedule today. And of course, at the 98% hydrogen filled side is a couple of years ago when we had issues with the ground umbilical carrier plate area, also known as the GUP. It's the same area, but a slightly different problem that caused us to scrub Discovery's first launch attempt back in November. We have gotten past, and you can see a close-up there of the ground umbilical carrier plate, which is essentially an attaching point to a ventilation line. And that pipe that leads away from the tank out to a flare stack on the pad and burns off excess hydrogen gas. In November, a quick disconnect section, the attaching point, basically the plug, if you look at the GUP as like an electrical outlet, the ground umbilical carrier plate is the outlet, and the plug itself to whatever apparatus you're looking at is the quick disconnect. And then an issue with the quick disconnect, hydrogen gas leaking from that section causes the scrub back in November. But so far today, we've had no issues with any hydrogen gas leaking beyond what normally leaks out. And no other issues are being worked right now. Turning our attention to the STS-133 mission in a little more depth now. The permanent multi-purpose module is Discovery's prime cargo on this last flight for Discovery. The PMM was a relatively late planned addition to the International Space Station's final configuration. It was converted from the multi-purpose logistics module, Leonardo, which was a pressurized cargo carrier that would be travel to and from the station during a shuttle mission. It would be loaded with supplies and experiments, temporarily attached to the station, unloaded, then repacked with cargo that would be taken back to Earth before being put back inside the shuttle's payload bay. The permanent multi-purpose module, as the name implies, now will be left at the station as a new crew module for the research complex. For the trip up to the station, the PMM is loaded with about 6,500 pounds of supplies, equipment, and experiments, including the first human-like robot to go to space, Robonaut 2. Before the PMM's hatch was sealed up last September, the STS-133 payload manager here at Kennedy, Scott Higginbotham, provided us with a walkthrough of what will become the station's newest crew module.
Hi, I'm Scott Higginbotham, and I'm standing here inside Leonardo, the permanent multi-purpose module. This module will soon be a permanent addition to the International Space Station, where it will provide much-needed storage space. This module is about 21 feet long, 15 feet in diameter, and weighs about 22,000 pounds. Stuffed inside, as you see around me, are about 6,000 pounds of cargo and equipment to go to the station for the crew to use on orbit. Ultimately, once this module is attached to the station, many more items will be stowed in this module, and it will become, in essence, the closet for the International Space Station. So surrounding me are some very large items, some of which are spare parts for the thermal control system. We have a treadmill for the crew to use on orbit to get their exercise. And then in these two large bags right here, we have components of Robonaut 2, an android-type robot that we'll be using on the station to learn more about how robots can help us in space.
Again, that was STS-133 payload manager here at Kennedy, Scott Higginbotham, who'll be joining us live here in the firing room number 4 of the Launch Control Center in a couple of hours. He'll go into a little more detail about all the supplies and equipment Discovery and its 6 astronauts will be taking to the International Space Station. So again, the launch team is not working any issues right now that would prevent us from launching on time at 4:50 p.m. Eastern at T-minus 3 hours, 48 minutes, and 7 seconds. This is Shuttle Launch Control. This is Shuttle Launch Control at T-minus 3 hours, 38 minutes, and 43 seconds and counting. The launch team is not working any issues right now that would prevent us from launching on time at 4:50 p.m. Eastern. Currently, forecasters are calling for a 90% chance of good weather for this afternoon's launch of Space Shuttle Discovery on its STS-133 mission to the International Space Station. We are in the middle of a process called tanking, which is filling the external fuel tank with about 535,000 gallons of liquid hydrogen, liquid oxygen. That process began on time at 7:25 a.m. Eastern. We went into liquid oxygen fast fill at 8:15 a.m. and into liquid hydrogen topping at 9:26 a.m. That means the hydrogen portion of the external tank is 98% filled up. So with the weather cooperating and no technical issues, including any issues right now with the ground umbilical carrier plate, the attaching point known as the GUP between gaseous hydrogen ventilation line and the external tank, the issue that actually caused us to scrub Discovery's first launch attempt back on November 5th, we've gotten well past that point in the tanking process with no leaks, and we are at that 98% side on the hydrogen tank portion, where there's a couple of years ago we actually had issues with the tank at the GUP, and have gotten past that with no hydrogen leaks. So I think it's fair to say that the launch team here is fairly confident that they worked out the procedures and have the GUP situation under control for this launch attempt. So with any luck, we won't have to be talking about it much more. And speaking of talking about what's going on, we turn our attention back here into fire room number 4 in the Launch Control Center. And as you've been hearing about, of course, this STS-133 mission will be the final mission for Discovery. And it will be the first space shuttle to be taken out of service before the program is retired this year. The Space Shuttle program has been doing a variety of things and activities during the last year or so to honor all the people who have dedicated their lives to space exploration through the Space Shuttle program. And of course, the team has also been paying tribute to the spacecraft themselves, which is being done in a unique way here in the firing room. 5 of those tributes are actually hanging on the walls of the Launch Control Center, firing room number 4. And joining us now in the firing room number 4, who will talk to us about these unique pieces of artwork, is the Shuttle Launch Director, Mike Leinbach.
Hi, Alan. How are you doing?
Thank you for having us on, coming and talk to us about something that's not exactly, now again, we talked about this, if we could do this particular segment to make sure we weren't working any issues, which means you're here, and that's a good thing.
That's a good thing. Yeah, you mentioned the GUP, and we're feeling very, very confident now that we have a good seal on the hydrogen vent arm, and so that should not give us any more problems the rest of the day. It performed just as it did in the tanking test, and so we should be good to go from that perspective.
So that allows us a couple minutes to look at something a little different from the actual launch countdown and tanking. People can't see, but looking straight out at the launch, at the team here and on the wall up there are 5 pieces of artwork. Where did this tribute art come from?
Well, it started about a year and a half or so ago. I wanted to commemorate the orbiters themselves and the teams that work on the orbiters. And so we came up with the idea of displaying something in the firing room where we launch out of. And what you're seeing now on the video, that's Discovery's tribute. What I asked each of the 5 teams to do was to design their own along a common theme and a common size and a couple of common threads. And so Discovery, Atlantis, and Endeavour teams went off and did that. My secretary, Amy Simpson, and I, we did Columbia and Challenger. And as you see on the videotape, they're very, very stunning tributes to the orbiters. They all have the mission patches that are representative of the missions that they've flown. Some of them display significant spacecraft that have been deployed. Challenger has the landing event, Columbia's first liftoff, and of course Columbia and Challenger both commemorate the 2 crews that were lost in the Space Shuttle program. So again, the Discovery, Atlantis, and Endeavour teams designed their own, and they're very, very stunning here in the firing room is the best word for them. The artwork themselves is 5 feet by 7 feet, so it gives you some idea of the scale of the firing room. And I'm very, very happy the way they turned out. I hope they stay in the firing room forever.
Now, besides the tribute art, which actually, being in the public affairs office, we get a lot of requests for the tribute art, and a lot of people downloading them off our website and circulated around when they first came out last year. It's that's one of the unique ways that the Space Shuttle program has been showing its appreciation for the workforce.
Right.
What are some of the other things that you and the managers are doing?
Well, we're doing a lot of things. We have a program where all employees can sign the wall in the vehicle assembly building. We have a special area in the VAB where they can sign. We'll put some plexiglass cover over it to preserve those signatures forever. We've given tours to the workforce of the ground floor of the orbiter processing facilities to allow workers that don't normally get into the OPF and see an orbiter to go there and really get up close and see what the orbiter looks like in the processing facility. We've done other things, for instance, on rollout days, we invite families and friends to come out here and view rollout with the big xenon lights on the stack as the vehicle goes from the VAB out to the launch pad. That's been very, very successful. I think for Discovery's second rollout, we had over 4,000 people out here to view that rollout. That's a very, very moving event, actually, to see the orbiter that close and going out to the pad for the final time. And there are other things we've got going on for the troops. Today, after launch, we'll be giving out a commemorative picture of Discovery that has her tribute display on it, and some nice words, and we'll do that with the remaining flights as well. So we're trying to give something to the troops that they can take with them as they move on to the next phase of their careers, wherever that may be, to remember the good work they did and be able to display something at home or in their next office and be proud of what we did for the American space program.
I hope I didn't need to say spoiler alert for people that you're about to, at the end of the after launch, you're going to give something away. I hope we didn't just give a surprise away to the launch team.
Well, I hope they're not listening to this broadcast right now.
They shouldn't be. They're working
That's right.
on the countdown. Now, you have to be dispassionate about doing your job, and clearly, I know you've heard this. You get this from reporters when we ask this question, and you're an engineer, and face it, you guys don't like to talk about this. You like to do the job, but you guys, the shuttle program personnel, including yourself, are very passionate about space exploration.
Well, we are, and we're passionate about exploration. We're passionate about this program, passionate about the vehicles themselves. You know, I've been here 26 years. This has been my entire adult life, and as with practically everybody in the program has well over 20 years. And, you know, we have some new hires, but mostly 20-year-plus people, and so you get attached to a program. It's a lot more than just our livelihood. It gets in our soul, and as it does with you, it gets into you. It's hard to describe to people who don't work in the space program what it's like. It's a very, very personal thing that we love to do, and it's going to be tough to see Discovery lift off today for the final time. I think what will be the most difficult will be on landing day, when we know that that's the end of her mission completely. But that'll be a great day. We'll celebrate Steve Lindsey and the crew coming back to KSC and delivering the permanent logistics module to the space station and R2. And so it'll be a day of celebration and also one of reflection.
Well, I have, since we obviously have the launch director here, for a minute I have to ask you, your job is going sometimes on your gut. What does your gut tell you about today?
Right now it feels good. The weather looks great. I just talked to Kathy Winters, the shuttle weather officer. She's holding 10% no-go, but I think if I pushed her, we'd be a little bit better than that. So I think weather's going to be good. The vehicle, you know, it's a machine, and so you never know until the final seconds on the clock if all pieces of the machine are going to behave. But right now it feels good. I've been in other countdowns where you just kind of get a feeling like it might not be just right, but so far so good today.
All right, well, let's hope that feeling keeps up. Mike Leinbach, Shuttle Launch Director, thank you for taking a couple minutes to talk about the tributes and the other things that are going on that the people don't always get to hear about on the other side of the Space Shuttle program. So thank
You're welcome. Glad to do it.
And as Mr. Leinbach just said, yes, we are not working any technical issues that would prevent us from launching on time right now at 4:50 p.m. Eastern. And as he said, a 90% chance of good weather for this afternoon's launch. So with that in mind, we'll hopefully keep counting down towards Space Shuttle Discovery's liftoff for its final flight to the International Space Station. So T-minus 3 hours, 29 minutes, and 10 seconds. This is Shuttle Launch Control.
Good job.
This is Shuttle Launch Control at NASA's Kennedy Space Center in Florida at T-minus 3 hours, 21 minutes and counting. Launch teams are not working any issues right now that would prevent us from launching on time at 4:50 p.m. Eastern. Currently, forecasters are calling for a 90% chance of good weather for this afternoon's launch of Space Shuttle Discovery on its STS-133 mission to the International Space Station. Managers and engineers are directing and monitoring Discovery's countdown on Kennedy's Launch Pad 39A from about 3.5 miles away in firing room number 4 in the Launch Control Center. We are almost complete with an operation known as tanking, which is filling Discovery's external tank with about 535,000 gallons of liquid oxygen and liquid hydrogen. That process began on time at 7:25 a.m. Eastern. Takes about 3 hours, so we are almost complete with that operation. The liquid hydrogen filling of the side went into stable replenish at 9:58 a.m. Eastern. And the liquid oxygen fast fill portion began on time at 8:15 a.m. Eastern. Stable replenish is a point when engineers have control of the propellant entering the tank, keeping it at a level 100%. Roughly about 40 minutes ago, the liquid hydrogen side went into 98% fill, and you slow down the flow of propellant into the liquid hydrogen portion of the tank. That's called topping. But because the tank is warm, a lot warmer than minus 423 degrees Fahrenheit, temperature of liquid hydrogen, some of it boils off, essentially evaporates, and therefore the propellant must be continually added to keep it at 100%. As the tank cools, the liquid becomes more dense, and by continuing to add propellant, it squeezes more propellant into the tank. And once the tank is filled, engineers then terminate the stable replenish phase, and the tank and propellant are then configured for launch. And we went into liquid hydrogen stable replenish at 9:58 a.m. Eastern. The first space shuttle flight of 2011 is also the last flight of Discovery, and Discovery's last mission is the first of the final 3 missions for the Space Shuttle program. In less than 2 months, NASA will be celebrating the 30th anniversary of the first space shuttle launch. But even a program that's been around for 3 decades and some people say has made launching into space look routine, still is finding new ways and unexpected ways to do things that it's been doing since 1981. And Discovery's final flight couldn't exemplify that better than it has. During their 11-day mission, Discovery's 6 veteran astronauts will bring the last crew module a shuttle will ever deliver to the space station. It's called the Permanent Multi-Purpose Module, or PMM, which essentially is a float-in closet for the space station. Discovery's astronauts woke up at 7 a.m. to start their launch day activities. The STS-133 crew is made up of Commander Steve Lindsey, pilot Eric Bowe, mission specialists Alvin Drew, Nicole Stott, Michael Barrett, and Steve Bowen. And Drew and Bowen will carry out the mission's 2 scheduled spacewalks. Discovery's STS-133 mission originally was scheduled to launch November 1st, but a series of weather delays and technical issues pushed it back to November 5th, and on that day, less than 2 hours into tanking, a hydrogen gas leak at the ground umbilical carrier plate, called the GUP, which is located on the external tank, caused us to scrub our first launch attempt. And then during tanking, a crack in the foam insulation on the external tank's inner tank section formed, and under the crack, small cracks on the tops of 2 support beams called stringers were located in that area, and that kicked off an engineering investigation into why the cracks formed in the first place. A tanking test in December, Discovery being rolled off the pad and then moved back into the vehicle assembly building, and that eventually led to an unprecedented but relatively straightforward strengthening modification being made to most of the stringers on the external tank before Discovery was returned to the launch pad on February 1st. But the GUP repairs and the external tank modifications weren't the only unusual things to happen between launch attempts. A few moments ago, I identified Steve Bowen as one of the astronauts and spacewalkers for this mission, but back on November 5th, Bowen was not a part of the STS-133 crew. He'd flown on Atlantis' STS-132 mission in May. But last month, Tim Coper, who was a part of the original STS-133 crew and was a lead spacewalker, was injured in a bike accident near his home in Houston and had to be replaced by Bowen. So this will be the first time that a shuttle astronaut had been switched out so close to a launch, and it will make Bowen the first astronaut to fly back-to-back shuttle missions, albeit 9 months apart. Coming up in a couple of minutes, we'll be turning our attention up 220 miles to the International Space Station. While Discovery and its astronauts are getting ready down here, the Expedition 26 crew will be ready to receive a new cargo spacecraft in about 35 minutes or so. The European Space Agency's automated transfer vehicle, Johannes Kepler, is scheduled to dock to the space station at 10:45 a.m. Eastern. And we're going to go live to NASA's Johnson Space Center in Houston for that docking coverage. And we'll do that now. In the meantime, we will be here on the media channel, and we'll be providing updates. There are no technical issues being worked, and we are on time for a 4:50 p.m. launch at T-minus 3 hours, 15 minutes, and 5 seconds. This is Shuttle Launch Control. Tank and other parts of the shuttle, the pad itself, looking for anything that might be amiss, including any buildup of ice or frost that could be a potential debris hazard. It takes about 2 hours for that team to perform its inspections. Then you go start at obviously the base level, then work their way up to the 255-foot level, and proceed down the fixed service structure of the pad to the 215, 195-foot level, which is also where the orbiter access arm and the white room are located. The 135-foot level, and then back down to the mobile launcher platform itself. Joining us now in fire room number 4 in the Launch Control Center, we have Charlie Blackwell Thompson, who's the head of NASA's Test Director's Office, and also is for this particular flight, the Assistant Launch Director for the STS-133 mission. Charlie, thanks for taking a couple minutes to talk to us and walk us through how the end of tanking went and how we're proceeding towards the next steps in the milestone for this countdown.
All right, Allard. Well, it's my pleasure to be here. I'll be happy to talk to you about how tanking went. Went extremely well this morning. We got into tanking right on time. We gave the go for transfer line chill down at 07:25, so just as planned. And we got our slow fill operations underway just after 7:30 for LH2, and then lock slow fill just after 8 o'clock in the morning. From slow fill, we get into our fast fill operations and then eventually into tanking, and we transitioned LH2 into tanking at 09:26. And as you know, that's an area where we pay close attention to the GUP, and we had very good performance there. So we've got a good GUP, and that's a good news story for us. And we got locks into topping at 10:14, and then shortly after that at 10:19 we got locks into stable replenish, and just before 10 o'clock I didn't report that we got LH2 into stable replenish. So both commodities are in stable replenish now. Our teams are into the pad performing their work. As you said, the closeout crew is currently up in the white room. The ASP is in the orbiter, preparing for flight crew arrival, getting the crew module configured, and our final inspection team is on the 215-foot level performing their inspection activities. And so everything is going extremely well from a tanking perspective, and also from getting our teams into the pad and the work that's currently going on.
As you mentioned a second ago, the GUP, that's the ground umbilical carrier plate, that's the connecting point where we had an issue that caused us actually to scrub our first launch attempt back in November. You guys have not seen anything amiss with that, right, this morning?
That is correct. Nothing amiss there. We watch it very closely all during tanking, but certainly during the transition to topping, we watch it very closely, and we did not see anything out of the ordinary. We had very good performance from the ground umbilical carrier plate. And
you mentioned the final inspection team doing its job out of the pad. Clearly, with all the issues that were related to Discovery's external tank, GUP being one, and then obviously the issues related to the stringers, the support beams on the exterior of the inner tank section of the tank. Will the inspection team be doing anything slightly differently? I know you guys were looking at having had additional cameras during the tanking process that were kind of looked at those areas. Anything else that that team will do differently and report back to you guys here?
Well, the team always does a great job assessing the overall, health and condition of the tank, and so they'll continue to do that. They look at a number of different things as part of their standard inspections. Certainly, as part of this inspection, well, I should say even back after we had the initial GUP issue back on STS-127, they incorporated some GUP inspections into the final inspection process, where they look at the position of the feet. We certainly know that the GUP is performing nominally, so that's not a concern, but they will go ahead and do the visual inspection on the GUP. In addition to that, they'll also be doing the ET, they'll be looking at the ET flange and the stringers on both the LO2 and the LH2 side, and they'll be photographing that with both regular cameras and also with IR cameras. So they will be taking some additional photography and some additional evaluation of that interface flange on both sides.
This is one of these Trivial Pursuit type questions. So we are currently in a 2.5-hour built-in hold at 3-hour point. The count officially kicked off at 3 p.m. Eastern time at the T-minus 43-hour point on Monday. People ask this all the time, why do you have holds? Why don't you just, if you want to start 3 days out, why don't you just count backwards from 3 days out instead of having these built-in holds? We have 7 in this count. What do you guys use them for?
Well, as you know, we use the countdown clock to synchronize work here at Kennedy Space Center and Flying Room 4 and at other centers across the country that are supporting Launch Countdown. And so we'll have milestones in the countdown that start at a certain point on the countdown clock. And so the reason we build in holds into the count is for a couple of different reasons. One is sometimes we want to take a collective pause before going into the next phase of operations. And then we also build them in to make sure that we have all of the operations and work that needs to precede a particular operation complete and ready to go. And so it allows us kind of a catch-up point, if you will. And if you think about where we have holds in the countdown, you can kind of see that they bracket a lot of the major milestones of work. I mean, we have a built-in hold at T-minus 27 hours and then another one at 19. And that hold brackets the PRSD, or the power reactant storage and distribution load, those LH2 and LO2 commodities that we load for our fuel cells. And so we have a hold point before, because that operation is sensitive to weather. Certainly we've had beautiful weather and it hasn't been a concern for this countdown. But in the event that we run late or there's some work that's being held up, we have a little bit of an opportunity to catch up. And then likewise, we have a hold after that. In the event that we did run long, then we have some buffer where we can go make up the time in the count, because if we just counted all the way through, we'd be more susceptible. It'd be much harder to make up if you had any kind of hardware delays or weather delays or anything of that nature. And likewise, at around tanking, we also have the hold at T-minus 6, which is prior to ET load, and then the one that we're currently in at T-minus 3, which is our hold after ET load. And again, we're protecting for the event that if tanking is late, getting the teams into the pad, getting everything configured and ready for the flight crew arrival right on time.
Clearly, I need to have built-in holds when I do yard work. That's what I need to schedule from now on. And you mentioned the milestones coming up. Obviously, besides having the crew get to the pad and get in the shuttle itself, what are some of the other major milestones you guys have coming up for the rest of the afternoon?
Well, you mentioned the flight crew arrival. They'll depart right around 1 o'clock, and they'll be at the pad about 25 minutes after 1, and then we'll begin their ingress right around 1:30. So that's a big milestone for us. Some of the other milestones that are coming up, our T-minus 20-minute hold, that is when we transition our computers on board the shuttle, the GPCs, or the general purpose computers. We transition them from a ground format into an ascent format, and there's a hold there, and just after that hold is when we make that, we transfer what we call an ops transition, and that's coming up just after 20 minutes. And then certainly our hold at T-minus 9, we enter that hold just before 4 o'clock, and that's normally a 40-minute hold, and that's where that's our last hold that's planned in the countdown. And so that's where we'll disposition any issues that may have arisen, if we have any. This has been a very clean countdown, and we really don't have anything at this point to really talk about. But we also look at our launch window, and that's when a lot of times we adjust that hold to sync up our actual launch time for that particular day. So really that's it in terms of the near-term activities. We'll finish up our work at the pad. Crew module will be configured. Final inspection team will finish up their inspection, and we'll have the crew coming out, like I said, just after 1 o'clock.
And you mentioned the T-minus 9-minute hold. That's, again, I think when you'll be joining us again on commentary, sometime during that T-minus 9-minute hold to talk about how things are proceeding in a few hours. So I'll let you go now to do the rest of it in between. And as we'll talk to you in a couple of hours, thank you for talking to us now. That's Charlie Blackwell-Thompson, head of our NASA Test Director's Office and also the Assistant Launch Director for the STS-133 mission. Again, as she said, start of tanking began on time at 7:25 a.m. Eastern and then wrapped up at 10:19 a.m. Eastern. The launch team is not working any issues right now that would prevent us from launching on time at 4:50 p.m. Eastern. We're going to take a couple-minute pause now in our launch commentary, and then we'll resume in about 5 minutes at 11:30 a.m. Eastern with NASA commentator Mike Curie. That's also when NASA's official launch blog will begin, 11:30 a.m. That's at www.nasa.gov/shuttle. That's also where you can follow anytime the final flight of Space Shuttle Discovery, its STS-133 mission to the International Space Station. At T-minus 3 hours and holding, this is Shuttle Launch Control.
This is Shuttle Launch Control at T-minus 3 hours and holding, with about 1 hour, 22 minutes and 50 seconds remaining in our hold today. Space Shuttle Discovery, the venerable veteran of America's human spaceflight fleet, proudly resting atop Launch Pad 39A here at NASA's Kennedy Space Center in Florida. Her wings outstretched and ready to soar into space for the 39th and final time. Discovery's odometer reads 142,917,535 miles, or 100 miles, and Discovery is going to add about another 4.5 million miles to that total on this 11-day mission when it roars off the launch pad at 4:50 p.m. today and races to 17,500 miles an hour in about 8.5 minutes. Shuttle Discovery is completing 27 years of service, the oldest space shuttle in the fleet, launching for the first time in August 1984 on mission 41D. And over the years, Discovery has achieved many notable accomplishments. Discovery deployed the Hubble Space Telescope on STS-31 in 1990, flew the first Russian cosmonaut on STS-60 in 1994, performed the first rendezvous with the Mir space station, guided by Eileen Collins, the first female pilot, on STS-63 in 1995. Reached the highest altitude ever for a shuttle flight on STS-82 in 1997. Flew Senator John Glenn back into space on STS-95 in 1998. Discovery flew the 100th shuttle flight, STS-92, in the year 2000 and performed the first and last space station crew rotations using a space shuttle. Discovery also was the return to flight orbiter after both the Challenger and the Columbia accidents. In total, Discovery has spent 351 days in orbit, to be exact, 8,441 hours, 50 minutes, and 41 seconds. Orbited Earth 5,628 times, flown 246 crew members to date, docked to the Mir space station once, and to the International Space Station 12 times, with the 13th time upcoming. Discovery was expected to launch late last year, but during tanking operations on November 5th, a gaseous hydrogen leak at the ground umbilical carrier plate caused a scrub, and subsequently the launch team spotted a crack in the foam insulation on the ribbed intertank portion of the external tank. This led to the discovery of cracks at the top of two of the tank's aluminum support beams, which are called stringers. So Discovery was rolled back to the vehicle assembly building on December 22nd, where X-ray scans revealed some other small cracks in three stringers on the backside of the tank, an area not accessible while Discovery was on the launch pad. While repairs and scans were underway, engineers at different NASA centers were testing a number of stringer mock-ups to help figure out the cause of the cracks. The testing and analysis determined it was a combination of weaker than expected metal in some of the stringers and stress built into the beams during the manufacturing process. Analysis also determined that along with repairing the cracked stringers, adding thin metal strips called radius blocks on the edges of the stringers' tops would help prevent future cracking. So with those repairs and modifications complete, and with the hydrogen leak solved, Discovery returned to Launch Pad 39A on January 31st, which brings us to today's launch of STS-133. At 7 this morning, NASA managers met and assessed our readiness to fill Discovery's external tank. They gave a go for that operation to commence, and it began at 7:25 a.m. Everything proceeded normally and was complete about 3 hours later at 10:19 a.m., and we entered our T-minus 3 hour hold where we are right now. The external tank is filled with more than 500,000 gallons of liquid hydrogen and liquid oxygen. The shuttle's power-producing fuel cells are working, the general-purpose computers are up and operating, and all the life support systems are activated, and everything is working as expected at this point. About 3.5 miles away from Discovery, launch controllers here in Kennedy's Launch Control Center Firing Room 4 are overseeing all the shuttle systems and verifying the step-by-step processes that will lead to an expected liftoff at 4:50 and 27 seconds p.m. Eastern Standard Time. Discovery's crew awoke at 7 o'clock this morning. They ate breakfast about 7:30, underwent standard medical checks at 8, and they've been making last-minute preparations for today's launch attempt ever since. The STS-133 crew features a newcomer following an unfortunate bicycle accident that sidelined mission specialist Tim Kopra. NASA selected Steve Bowen to fly and to perform the 2 spacewalks that Kopra was expecting to do. Bowen is one of the top-rated spacewalkers in the astronaut corps. He's fully trained for the mission, and he becomes the first U.S. astronaut to fly on back-to-back missions, having flown on STS-132 last May. The commander of the mission, Steve Lindsey, a spaceflight veteran, and his pilot, another veteran, is Eric Bowe. In fact, this is an all-veteran crew that's also comprised of mission specialists Mike Barrett and Nicole Stott. Right after the launch tower is cleared today, Discovery will perform a roll maneuver which points it precisely on the proper 51.6-degree trajectory to catch up to the International Space Station, our target in orbit. At the time of liftoff, the space station will be about 220 miles above the South Pacific, and as the shuttle rockets to the northeast, it will climb and accelerate to 17,500 miles an hour to begin the chase. STS-133 is an 11-day mission to the space station. It will deliver the Permanent Multi-Purpose Module, or PMM, which was converted from the Leonardo Multi-Purpose Logistics Module to withstand the harsh elements of space. The PMM will provide additional storage for the station and experiments that may also be conducted inside of it, such as fluid physics, material science, biology, and biotechnology. Discovery also will carry critical spare components to the station and the Express Logistics Carrier 4, or ELC-4, which is an external platform that holds large equipment to be transported using the unique capability of the shuttle. Also, Robonaut 2, or R2, will become the first human-like robot in space when it flies inside the PMM to become a permanent resident of the station. The STS-133 mission will feature 2 spacewalks conducted by Bowen and Drew to do maintenance work and install new components on the station. Here inside Launch Control Center, the countdown for Discovery's launch is continuing on schedule. The window opens at 4:45 p.m. today, and our preferred and planned launch time is 5 minutes later at 4:50 and 27 seconds p.m. Eastern Time. We're at T-minus 3 hours in holding. This is Shuttle Launch Control. This is Shuttle Launch Control at T-minus 3 hours and holding. About an hour and 12 minutes remaining in our hold. Space Shuttle Discovery's journey to today's launch countdown has had a couple of challenges along the way, and here to tell us about the processing is Discovery's Flow Director, Stephanie Stilson.
One of the first things we do after the orbiter returns from a mission is remove the Space Shuttle main engines so that they may begin the refurbishment process. The yellow piece of equipment that you see here is the modified heister that we use to remove the main engines from the orbiter. Removing engines is a very slow and methodical process of ensuring everything is lined up correctly as the engines are removed from the aft compartment. Each engine is 14 feet long and 7.5 feet wide, providing 375,000 pounds of thrust during liftoff. As each engine is removed, it is transported to the engine shop located next to Orbiter Processing Facility Number 3. Engineers and technicians then refurbish the engines in preparation for their next use. During the STS-133 processing flow, the right orbiter maneuvering system, or OMS pod, was removed from Discovery to address the failed helium isolation valve issue from the previous mission. The pod was lifted to the transfer aisle prior to being transported to the hypergolic maintenance facility here at Kennedy Space Center for servicing and maintenance. On May 11th, the external tank 137 arrived by barge from the Michoud Assembly Facility in Louisiana. The barge, named Pegasus, is 200 feet long and 35 feet wide and was built specifically for transporting the external tank. Within the confines of the turn basin, a commercial tug carefully assists Pegasus as it maneuvers up to the dock. The external tank inside Pegasus is 154 feet long, 27.5 feet in diameter, and holds over 500,000 gallons of propellant. The tank weighs over 58,000 pounds empty. Once on dock, we use the external tank transporter to move the tank off the barge and over to the vehicle assembly building. While the entire offload process takes technicians and engineers approximately 2 hours, the actual travel time is only 10 minutes for the quarter-mile trip. Although the external tank looks like one extremely large tank, it is actually made up of 2 internal tanks. The liquid oxygen tank is at the top or pointed end, and the liquid hydrogen tank is at the bottom. The function of the external tank is to provide liquid hydrogen and liquid oxygen to the 3 Space Shuttle main engines. The aft bipod struts and propellant feed lines you see here connect to the orbiter. The outside of the external tank is covered in a polyurethane foam that protects it from extreme temperature variations seen during flight. Back in the orbiter processing facility, Discovery's mid-body is closed out in preparation for rollover. The yellow strongbacks you see here assist the payload bay doors to close in the gravity environment of Earth. The KU-band antenna is used to transmit and receive video and data communications with the ground. The payload bay doors will be reopened again at the pad for payload installation. After spending 119 days in the orbiter processing facility, completing all required maintenance, testing, and checkout, Discovery is now ready to move to the vehicle assembly building, where it will be mated to the external tank and solid rocket boosters. Similar to the tank transporter we saw earlier, the orbiter has a unique transporter as well. The Orbiter Transport System, or OTS, has 76 wheels on 19 axles and was built specifically for the orbiter. Once Discovery is safely in the vehicle assembly building, we begin the process of lifting the orbiter off the transporter and joining it with the external tank and solid rocket boosters. Discovery is secured to the transporter using the same attach points that will eventually connect it to the external tank. There are 2 structural connections in the aft and 1 in the forward. A sling is connected to the orbiter so that cranes can lift Discovery and move it into the vertical position. Lifting the 200,000-pound orbiter requires use of a 350-ton crane and a 250-ton crane. Once Discovery is hanging in the vertical position, the smaller of the 2 cranes is disconnected, and the larger crane lifts the orbiter up and over the transom into the integration cell. It takes approximately 12 hours to lift the orbiter and get it into the mate position. Technicians closely monitor the movement of the orbiter and are in radio contact with the crane operators at all times. Once in place, the orbiter is bolted to the external tank and the sling is removed. Now that the orbiter has been mated, we are ready to move the complete shuttle stack out to the launch pad. The stack is moved by a crawler transporter which weighs 6 million pounds and uses 150 gallons of diesel fuel per mile. A unique viewing opportunity was provided to Kennedy Space Center personnel for the evening of rollout. Employees could bring family and friends out to the turn basin to enjoy the beautiful view as the STS-133 stack slowly made its way to the launch pad. Instead of wheels, the crawler transporter has 8 tracks with 57 cleats per track. Each cleat weighs 1 ton. At speed of less than 1 mile per hour, it normally takes approximately 8 hours to travel just over 3 miles from the vehicle assembly building to Launch Pad 39A. Discovery arrived at the launch pad on the morning of September 21st. Once at the launch pad, we spent about a month doing a full system checkout of the tank, boosters, and orbiter in preparation for launch. Here you see the STS-133 primary payload, the Permanent Multipurpose Module, or PMM, carefully being installed into Discovery's payload bay. Following final closeout inspections of the installed payloads, the payload bay doors are closed for flight. The STS-133 crew joined the Kennedy Space Center launch team for the Terminal Countdown Demonstration Test, or TCDT, in mid-October. TCDT is a full dress rehearsal of the final hours of launch countdown and provides key training for both the flight crew and the launch team. The flight crew checks the fit of their spacesuits, practices emergency evacuation procedures at the launch pad, and inspects their mission cargo in the shuttle's payload bay. This training allows them to familiarize themselves with the vehicle and become acclimated with safety equipment and procedures. Astronaut support personnel representatives assist the crew during the TCDT operations.
I agree.
On the morning of November 5th, launch countdown was scrubbed due to a leak at the ground umbilical carrier plate, or GUP, interface on the external tank. The GUP is located at the end of the gaseous hydrogen vent arm on the fixed service structure of the launch pad. During scrub turnaround operations, a foam crack was also found on the liquid oxygen interface flange of the tank. Both the GUP leak and the foam crack would require substantial investigation and evaluation by the Space Shuttle program over the coming weeks. The GUP plate holds a large diameter pipe that collects excess hydrogen gas from the tank as it is being filled with liquid hydrogen. The venting system funnels the gas to a larger pipe that then takes the hydrogen gas down the fixed service structure of the launch pad and out to a flare stack that safely burns off the excess hydrogen. At liftoff, the GUP retracts away from the tank, cutting off this connection. The vent arm pulls back to the tower and safely away from the shuttle. Because the GUP's connection to the tank is so important, it has sensors in place to watch for leaking hydrogen. Launch controllers track these readings closely, and if any of these readings are outside the allowable limits, the countdown is halted. After discovering the GUP leak during countdown, the external tank was drained of its liquid hydrogen and liquid oxygen and cleared of excess hydrogen gas. At that point, it was safe for technicians to begin collecting data to better understand and analyze the leak. An investigation team was formed to fully evaluate the hardware configuration, installation, and functionality and determine if any modifications would be necessary. Teams performed an initial inspection of the flight seal and quick disconnect prior to sending them to the lab for extensive micro-level inspections. As part of the investigative effort, the complete ground umbilical carrier assembly and vent line was disassembled and inspected. The same repair is performed on the other crack stringers found at the launch pad. In addition, a radius block modification was also performed on the intertank stringers. The radius block modification provides additional structural support in areas known to carry much of the structural load of the external tank. These radius blocks essentially fit over existing stringer edges through which securing rivets are installed to provide additional structural support. Once all repairs were made to the external tank, the stack was again placed atop the crawler transporter and carefully rolled out to Launch Pad 39A on January 31st. Brilliant xenon lights illuminated the vehicle, creating a spectacular view for everyone present. To verify the integrity of these repairs, an instrumented tanking test was performed on December 17th. Numerous strain gauges and temperature sensors were installed to record data from the tank as it chills and warms again during the loading and offloading of propellants. Following the completion of the instrumented tanking test, we rolled the shuttle stack back to the vehicle assembly building for further non-destructive evaluation, or X-rays, of the external tank stringers that were not accessible at the launch pad. Rollback occurred on December 22nd, and engineers immediately began inspecting and evaluating the external tank. X-rays revealed an additional 4 small cracks on 3 stringers. These stringers would require the same repair as performed on the other cracked stringers found at the launch pad. In addition, a radius block modification was also performed on the intertank stringers. The radius block modification provides additional structural support in areas known to carry much of the structural load of the external tank. These radius blocks essentially fit over existing stringer edges through which securing rivets are installed to provide additional structural support. Once all repairs were made to the external tank, the stack was again placed atop the crawler transporter and carefully rolled out to Launch Pad 39A on January 31st. Brilliant xenon lights illuminated the vehicle, creating a spectacular view for everyone present. Once back at the launch pad, a full system checkout of the tank, boosters, and orbiter was completed in preparation for launch. STS-133 is the 133rd Space Shuttle mission and Discovery's 39th and final mission.
Thank you very much, Stephanie. It's nice to have you here in the firing room next to us today.
It's great to be here. Launch day is always a good day.
It is a good day. But this has to be a little bit of a bittersweet moment this time around since we're talking about Discovery's last flight, and you've been with the Discovery team for a long time as the flow director. How How does it feel today?
Well, you're right. It has been bittersweet. Whenever we achieve major milestones along the way, say rolling out of the OPF, rolling out to launch pad, there tends to be some tears there, tears of joy, excitement to be past that major milestone. This time around, there was a little bit of an underlying sadness as well, because it's the last time we're going to be processing Discovery for flight. So the team, although excited about being here on launch day, there is some emotion, and I expect that when we lift off today, we'll see quite a bit of emotion here in the firing room and with the rest of the processing team who are outside with their friends and family ready to watch liftoff.
And it will be another emotional moment when Discovery lands back here at Kennedy Space Center in about 11 to 12 days. When that happens, what will happen with Discovery?
Well, what we'll do initially is basically business as usual. We go into what we call our down mission processing. And basically that's about a month worth of work where we're first safing the vehicle, getting it back into the orbiter processing facility, draining hazardous commodities so that we can get access to the vehicle and put personnel in there. At that point, the main thing we're looking for is there anything with Discovery that we saw on orbit or in inspections that we do on the ground that would require us to go do anything different on the other two vehicles that still have a flight to go. So we'll do that, do those inspections and so forth. At that point, then we get into what's the new part of our job, and that'll be the transition and retirement of Discovery. And the first stage for that is called the in-state safing. And basically at that point, the vehicle has been safe enough for technicians and engineers to work on it, but now we need to make it safe enough for the general public to be around and close up with the vehicle itself. So there's different commodities that we'll have to offload to ensure hydraulics, ammonia, cryogenics, those hypergols, those kind of things, as well as pyrotechnics and so forth. So we'll take care of that. At that point, we'll also look to pull out the main engines. Those will be removed and reused. We'll also have pulled out payload components that are necessary. And then there are going to be some avionics boxes and components of the vehicle that will be pulled out and used for future type of research or future projects and things like that. So we'll do that. The next stage then at that point is to prepare Discovery to be ferried to the display site. So we'll have to put the OMS pods and the forward reaction control system back on, put engine simulators in and so forth, and get it ready to go out to the mate-demate device out by the runway, load it up on the shuttle carrier aircraft, and then ferry it off to its final destination. When we get there, we have the task of then offloading from the SCA, taking Discovery into its display area and doing the final touches to get it into a preparation for being displayed by the general public.
And your team will be involved in all that process?
Absolutely. All the folks that have worked on all the vehicles throughout the history of the shuttle program, same people, engineers, technicians, quality, safety, planners, schedulers, they'll all be involved with this transition retirement activity as well.
That's great. Well, since your team has been working so hard on this shuttle for so many years, some folks came up with an idea. There's a traditional liftoff line that the Public Affairs Office commentators utter at the time of liftoff, and your team was asked to come up with a liftoff line this time to be used at the time of liftoff. Can you tell us a little bit about that process? And,
sure.
And without revealing the line, maybe...
Yes, I won't steal your thunder and read the line by any means. No, what a great honor to allow the team to come up with that final liftoff line. And so basically what I did was I sent an email out to the leads of the Discovery's team to basically describe what we were looking for and give examples of previous liftoff lines, the criteria and so forth that go with that. And then all the leads then dispersed it out through email to all their distribution lists. That's the quickest way we can get the word out is via email. At that point, then individuals were able to submit those ideas to me, and I consolidated them and passed them on. And then the selection committee actually was able to pick the one they thought was best, and I think they did a real good job with that. And are we allowed to say whose selection was?
Yes,
okay.
Please do.
Mary Butler of the United Space Alliance was the one who submitted the winning liftoff line, and Mary has been with United Space Alliance working shuttle since '96. She's in the guidance navigation group, so basically she does all the systems checkout and testing of the navigation systems and radar and so forth. And she's actually a member of the Prime launch team, so she's in here today getting ready for liftoff. And her husband John as well is also on the Prime launch team. So really excited for Mary to have submitted that, and we're really excited to have everybody hear it.
Yep. Well, we're going to be excited to speak it. So that's wonderful, and we really appreciate Mary's line and the effort that your whole team put in on coming up with those liftoff lines. There were a lot of good ones, and it was a hard choice for the selection committee.
I can imagine. We're all very excited and very proud to be part of Discovery's team. So thank you for talking to me today.
You bet. Thanks again for being with us, Stephanie.
You're welcome.
This is Shuttle Launch Control at T-minus 3 hours and holding, and a little under an hour remaining in our hold here at this point. Everything is going well in the countdown towards the liftoff of Space Shuttle Discovery today. There are no major technical issues in work. Weather looks like it's going to cooperate. There is a 90% chance of go weather today, with only a very slight possibility of a southeasterly breeze bringing in some low clouds and possible rain showers, but that again is only a 10% chance for that. The flight crew is awake. The final inspection team is reviewing the external tank, the launch pad, and the Space Shuttle Discovery in search of any possible debris hazards, the formation of ice. The closeout crew is in the White Room preparing Discovery for the cruise entrance later on. And we are pleased to be joined here in the firing room by Scott Higginbotham, who is the payload manager for STS-133. And Scott, it's nice to have you here today.
It's certainly great to be here today.
You have been following this flight for some time with the delays that we've had, and you've had a number of payloads ready to go. And can you just kind of briefly tell us a little bit about that?
Yeah, absolutely. We closed the payload bay doors back on the 16th of October of last year, and at that point our two primary payloads for this mission, the Permanent Multi-Purpose Module and the Express Logistics Carrier 4, were closed out and ready to fly. And they've remained that way ever since, and they continue to be ready to go today, and if we need to delay for whatever reason, we'll continue to wait. So the beauty there is they're fairly insensitive to the passage of time, so we left the doors closed and followed the orbiter and went with it when it went back to the VAB and then back to the pad again. Up on the forward end, in the crew module, we did have a number of experiments that we removed after the last attempt. We turned them back over to the experiment developers. They refurbished them, and we reinstalled them both on Monday and yesterday, and finally all of those are on board and ready to go fly.
So no significant changes caused by the delays, and you're ready to go. And we have a tape, I know, that we can roll that will allow you to explain a little bit more about what we're doing. So we'll roll that tape.
Yeah, we're going to compress about 18 months of work into about 5.5 minutes. All right, this is a C-5A military aircraft. It delivered Express Logistics Carrier 4 to us from the Goddard Space Flight Center back in mid-August of '09. The Goddard team, under the direction of Kevin Carmack, put the ELC carrier together, and then we here at KSC with our Boeing colleagues finished the outfitting of that element. The Permanent Multi-Purpose Module Leonardo returned on the 19A STS-131 mission back in April of last year, and it returned to our building on the 26th of April, where we pulled all of the cargo out from that last flight and started the modification process to get it ready to become the PMM. That work was performed predominantly by our Italian colleagues from Thales Alenia Space under the direction of Roberto Barreto. They did a wonderful job, and by the end of July they had the element converted to a PMM. During our processing flow, we perform a number of tasks to get the module ready to go fly. This will be the 8th flight of Leonardo, and in this scene you can see a simulator of the docking mechanism on the station that we made up to the docking mechanism on the module every flight to ensure that it's going to seal properly against the station. This time for final assembly and installation onto the station. Here's ELC-4 being moved over to our element rotation stand. We did that periodically throughout the floor, as there's a top surface and a bottom surface on that element, and we need to be able to flip it over like a pancake. And once the internal modifications were completed in early July, the external mods continued on for a while. We started our rack installation process. We have 14 racks flying up with us in the module and carrying up a total of 8,500 pounds of cargo. The external mods continued in parallel with that, and this is a view of some of the Thales Alenia Space personnel installing some of the modified blankets and shielding on the exterior of the vehicle. These new shields were installed to help the vehicle survive the 10 years it's going to see in space. The very large ORU flying on ELC-4, the one and only, is a thermal radiator for the exterior of the station. We hope we never have to use it, but we'll have it pre-deployed there if necessary, and that's a shot in August of us installing that. Once ELC-4 was completed, we lifted it up and mated it to its keel assembly. It uses this keel assembly when it's installed in the orbiter to survive ascent loads. The keel does stay behind when the element is deployed to the station, and will be one of the few things that will return home in Discovery's payload bay. After that, the element was weighed and installed into our transportation canister.
Robonaut 2. R2 arrived at KSC in early August and went through about a week of post-delivery checkout and preparation activities. In the end, after they checked out all of the operations of the robot, we packaged it up into its launch enclosure and installed that launch enclosure into the module for flight. In early October, on the 5th, the element was lifted out of its work stand for the last time. We weighed it, calculated its center of gravity, and then moved it over into our transportation canister. In this view, you can see it being lowered down onto the load cells that are used to actually measure the weight of the element. The ELC-4 element had been installed in the canister just prior to this, so the PMM was the second and last element to go into the canister. The plastic you see there draped over the docking mechanism is intended to protect us from some minor contamination that we might see during our transport out to the pad. Was removed during our final closeout operations out at Pad A. Once both elements are in the canister and the doors are closed, it's moved over to our canister rotation facility where it's tilted up on end atop the transportation mobile transporter that we use. And on the 7th of October, my wedding anniversary, we delivered both elements in the canister out to the pad. We usually do this in the middle of the night to avoid traffic and because the weather is generally better for us. It takes about 4 hours to get there, very slowly and very carefully. Once up on the pad surface, we hoist the canister up into the rotating service structure, which you can see has been pulled back away from the orbiter. Inside the rotating service structure, there's a large gantry called the Payload ground handling mechanism that can actually reach in and extract the payload elements from the canister. The canister can then be lowered and taken away. The RSS is rotated around the orbiter, and the elements are installed by that ground handling mechanism into the orbiter. Once we made all the appropriate electrical connections and did our final closeouts, hey look, that's me. We performed our final closeouts out at the pad, and on the 16th of October, we closed the payload bay doors for flight. Again, that was quite some time ago, but I'll never forget that day. A lot of us like to go out and watch that because that's our last opportunity to basically blow our hardware a kiss goodbye. And that's where we've set ever since. Again, we've gone a few miles horizontally, and hopefully today we'll go a few miles vertically and get these two elements in space and attached to the International Space Station where they belong.
It's quite a lot of work, quite a lot of detailed work to get the payloads ready to go fly into space.
Absolutely. It's a team effort with great folks all around the United States and all around the world for that matter. We spent a lot of time on this mission in particular working with our colleagues from Italy, and that's been an absolutely wonderful experience.
Absolutely. Well, we also have another tape that we wanted to play in which you sort of give us a tour of the permanent multi-purpose module. We look forward to taking a look inside.
All right, great.
The permanent multi-purpose module, once again, is a modified version of the Leonardo multi-purpose logistics module that flew in space 7 times, I believe, and carrying hardware to and from space. And in this case, it's been modified to become a permanent module that will not come back to Earth.
Right. This module is going to serve as that extra closet or extra garage bay that you always wish you had. You know, the station's growing and the cargo on board is taking up a lot of space, so we just need some more places to stash things, and the PMM will provide us some very much needed space. So this is a view looking in the hatchway, and I think next we're going to proceed on inside. This was taken during our final phases of our closeout activities, so all of the cargo at this point is on board. The great big white box you see in the back in that original image was Robonaut 2 packaged up in his enclosure, and you can see him there on the far right hand side of the screen right there. A lot of cargo items are they're large and oversized, so they're in special containers that we strap into place, and you can see that they're covered in foam for protection. We have an extra treadmill that we're carrying up, some spare parts for the thermal control system for the station, food, all manners of things that the crew needs to live and work in space. Again, 8,500 pounds of cargo. Some of that cargo is going to be used right away.
Some of it's going to be used later on over the station's lifetime. And certainly much of this volume inside this module will be filled up with additional cargo items once the element gets on orbit and attached to the station. There are a few empty rack bays. We don't have enough performance to carry up a full module on this flight, so those empty rack bays will again be filled with cargo later on. And here's Robonaut 2 again running through his paces. He's an absolutely amazing device. He will teach us a lot about how robots can help us in space, both inside the station and ultimately outside the station, and perhaps one day we'll be able to use robots that can trace their lineage back to Robonaut to do some of the more dangerous and maybe mundane things in orbit so that the crew can be freed up and protected from those things. Leonardo is basically a very low mileage used spacecraft, the way we look at it. He's flown for about 90 days in space and cumulative time, and has traveled, I think, 40 million miles in total so far. But over the 10 years that we expect the module to stay in space attached to the space station, we have calculated that roughly it will travel about 10 billion miles, and so it's got a lot of good miles left in it. We're sad to see Leonardo go. He's been part of our family for over a decade, but we're all excited to see him put to good use as a permanent addition to the space station as opposed to ending up in a museum somewhere.
Absolutely.
So it's a real thrill for my team to be here today. It's been a long journey. It's been an exercise in patience, but we're expecting the payoff today, and actually a few days downstream. For us, really the big day is the day that the element's deployed and attached to the station and onto its new permanent home.
That's just days away. I think today looks like a good day, so we'll keep our fingers crossed.
Yes, indeed. Looks like a good day to go fly.
All right. Thank you very much, Scott.
You're welcome.
This is Shuttle Launch Control at T-minus 3 hours and holding, and a little under 40 minutes remain in our hold today. NASA has used humans and robots to explore space for some time, and on the STS-133 mission, as you've heard, Space Shuttle Discovery's crew will be taking up a new type of crew member to the International Space Station, Robonaut 2, a robot astronaut helper. And just a few moments ago, NASA Payload Manager Scott Higginbotham gave us a little peek at Robonaut before it was packed for flight. And here with us now is Rob Ambrose, Acting Division Chief of the Software, Robotics, and Simulation Division at the Johnson Space Center in Houston. Rob, thank you very much for joining us.
And thank you, Mike. It's a pleasure to be here talking about Robonaut 2 today.
Before we get into all the wonderful things that Robonaut 2 can do, can you tell us a little bit about how the project got started?
Well, we actually got our first funding from Dave Lavery at NASA headquarters 15 years ago as part of the TriWeek program. He and I were just talking about that the other day in his office. Little did we know where it would go, but we had a vision and we've persevered. We've built multiple robots over the years in the Robonaut family, maturing the technology, and here we are today, launch day for one of the Robonauts to go into space. It's a dream come true.
I bet it is. And General Motors is also involved in this project with you?
Yeah, General Motors has been a terrific partner for us. They share our vision of robots that can safely work side by side with people as our assistants helping us do work.
Can you tell us a little bit about what Robonaut 2 will do once he's unpacked and assembled and put to work in space?
Sure. We've got kind of an evolutionary plan for the Robonaut 2 that'll be on orbit. It's going to start out packed and then unpacked by the crew. It has a pedestal that it'll be mounted on inside the space station. So it won't be able to move around on its own, but it has this nifty task board that will be set up by the crew with all sorts of challenges for the robot to manipulate. These are things the robots have done very well on Earth in gravity. So the question is, how is it going to do in zero-G, where all those interfaces have no gravity loads? There are things that you and I could do pretty easily, knobs and switches and plugging in and out connectors, things that are really built for humans to work with. The challenge is for a Robonaut to be able to do those in zero-G. Now it'll evolve from there. We would like to add legs, and we're working on those now to allow it to climb around inside station, because we really don't want to have to bring work to the robot. We would like it to go where the work is to be done,
right, and
then evolve to go outside and go EVA.
In a couple of moments, you're going to show us a video of Robonaut in action, and one of the most important features is that he is safe. Can you explain a little bit about that?
Safety is really at the core of the Robonaut concept. When you build a robot to work around people, it has to be safe. It has to be something that you can kind of anticipate where it's going. Just think of an assistant that was erratic or you couldn't really anticipate. That wouldn't be a good assistant. You want an assistant who is safe, is not going to hurt you. If they hand a tool to you, they're not going to poke you with it. That's what we want in a robot. GM has that same interest in robots that can work with people. It's really at the core of the machine. And unlike you see in the video beautiful articulated fingers that are able to handle all the same tools that the astronauts can work with on orbit. It would be much easier to ask people to redesign all those tools so that a simpler robot could handle them. But we stepped up to the challenge of accepting the human as really the de facto standard. So that way these interfaces can be built for both humans and robots. You see the robot is strong. In a gravity environment, that really is pretty hard on people. You see the robot handling a 20-pound dumbbell, and it's doing it the way physical trainers teach humans to do it, which is nice and slow. It's not cheating. Robots don't cheat, right?
Right.
It's also able to handle objects that are stiff with both hands. So here it's handling a carbon tube that's really stiff. Now, a normal manipulator would possibly damage one of its arms handling such a device. That's because it's got a soft technology that allows people to interact with it. It's safe at its core. That was the challenge. A robot strong enough to do work, but safe enough to be trusted to do it right next to you and I.
Well, that is a challenge, and you wouldn't want to get too firm of a handshake with a robot, I would think.
Well, here's a demonstration of how it can interact with people. It was trying to go through that pre-programmed motion, but Dr. Ron Diffler there got in its way. Now, it didn't do anything dangerous. It just did something very natural. It just paused. It detected the contact that Ron had, and it didn't do anything dangerous. It just paused and waited for Ron to basically get out of his way, and then the robot went back to working. That is always present in the Robonaut. Every time it's moving, it's got that safety, kind of the core of its motion control. Here's another thing that the robot's doing that's very unusual. You don't normally find robots handling soft goods, floppy, flexible fabrics like this space blanket. Very unusual. Normally robots can only handle things that are very deterministic and placed for them. Here's another object that's kind of flexible inside. That's its NASA travel orders that it's got in that manila envelope, and it's pulling them out. That is actually the robot that is packed inside the station, inside the shuttle right now, ready to go. This was shot before it was brought here to KSC.
Complete with NASA travel orders. That's excellent. Well, that's been it's very interesting, and we are all looking forward to getting Robonaut 2 up to the space station and put into use. And we appreciate your time today, Rob, to fill us in.
Thank you so much, and I'd just like to thank the Robonaut engineers, that are the real Robonauts that make this happen. Thank you very much, Mike.
All right, thank you.
All right. This is shuttle launch control at T-minus 3 hours and holding. 31 minutes, 20 seconds remaining in the hold today, and the final inspection team remains making its survey of the space shuttle, the launch pad, the external tank, pad surfaces, to ensure that there are no hazardous debris sources that could present a problem today. And at the same time, the closeout crew has been on station since we completed filling the external tank earlier today, preparing the white room for the arrival of the astronauts, who at this point are receiving a weather briefing from Mission Control in Houston. The ascent team of flight controllers there, led by Flight Director Richard Jones, has been on console since 11 o'clock this morning. And after the weather briefing, the astronauts will don their orange launch and entry suits and be preparing to make their way to the launch pad. During their weather briefing, though, we thought we would take a moment here to talk to Lieutenant Colonel Patrick Barrett from the 45th Squadron at Cape Canaveral Air Force Station, one of our weather experts who works in tandem with the Spaceflight Meteorology Group in Houston to help predict the weather here for launch at Kennedy Space Center and for potential abort landings around the globe. Yes. Welcome, Colonel. Thank you for being with us. Oh, my pleasure.
Things are looking up today?
Yeah, right now we're having great weather here, and I know for everybody that's looking forward to the last launch of Discovery, it's going to be a great view.
For the most part, we have very few concerns here at Kennedy Space Center for launch. The only concern we do have is there is some clouds and some light shower activity out over the water that we're continuing to monitor, and really that's the only concern we have right now. The nice thing is the showers that we've seen come over land have dissipated, which is a good sign for weather here at Kennedy Space Center coming into launch.
Do we expect that with afternoon heating that will help us, or do you think that is more detrimental to us?
Well, anytime you get that afternoon heating, you have a chance of a little bit more development and a little more lift. But right now we have a pretty good area which is helping to inhibit any development, and so we're hoping that'll continue throughout the afternoon, and things are looking pretty good. We'll see our wind shift around out of the southeast, which is out over the water, so we are going to have that afternoon breeze coming through. But all indications right now is that things are looking very good for a launch this afternoon.
And the only concern would be if these low clouds or showers were to drift within 20 nautical miles of the shuttle landing facility. It's more of a concern for an abort landing than it would be for launch.
Correct. Right now, the way those clouds are coming in, it is more of a concern for the return to launch site constraints that we have within 20 nautical miles right now than it is for launch. Of course, if it does come close enough to launch pad, the launch weather team at the 45th Weather Squadron is continuing to monitor that against the launch constraints as well.
Okay, great. And the last that I had heard, we had at least 2 good transatlantic abort landing sites forecast for today. Zaragoza and Morón in Spain. Both were forecast to be go, and we only need 1, so that probably is not going to become an issue for us today.
No, it doesn't look like it at all. Spaceflight Meteorology Group, their forecast, they said they have some concerns for winds at Istris, but both the other 2 sites, Zaragoza and Morón, both look great, and it looks like everything's good as far as TAL sites go.
Excellent. All right, Colonel Barrow, thank you once again for your time, and we look forward to an on-time liftoff at 4:50 p.m. Eastern Time, and we'll hope that the weather cooperates with us. It's looking good.
Right.
Thank you.
Bye.
This is Shuttle Launch Control. We are still at T-minus 3 hours and holding, 23 minutes, 20 seconds remaining in the hold. And we're standing by to receive live television of the astronauts in the operations and checkout building here at Kennedy Space Center. They'll be suiting up in their orange launch and entry suits, which officially are known as the Advanced Crew Escape System, or ACES. And we'll be taking a video and showing that operation to you here shortly. The crew has been up since 7 o'clock this morning, preparing for today's launch. We're working no major technical issues, and weather is looking pristine, with just a very slight chance of clouds moving in from the southeast, but still a 90% chance of go weather, and good weather forecast for the transatlantic abort landing sites. The closeout crew at Launch Pad 39A has the orbiter prepared for the crew, and fellow astronaut Kay Heyer is serving as the astronaut support personnel, or ASP, today. Kay has logged over 711 hours in space, and she flew as a mission specialist on STS-90 in 1998 and on STS-133 last February. She's been inside Discovery's cockpit performing communications checks with the Launch Control Center and Mission Control in Houston. And she also has been completing the pre-ingress switch list used to verify that the shuttle's cockpit switches are all in the proper position and configuration for the flight crew's arrival and our launch attempt today. Also, the cabin air temperature has been adjusted to comfortable levels, making sure Discovery is ready for the arrival of her flight crew today. The final inspection team, along with the closeout crew, made their way out to Launch Pad 39A at the completion of our external tank loading today. They began at the mobile launcher platform level and then took the elevator up to the very top of the stack and have been working their way down using a number of devices to look for the formation of ice or anything out of the ordinary. They're taking photographs digitally using infrared devices, and they have the ability to transmit the photographs back to the Launch Control Center, where a team is standing by to review them and help to ensure that everything is go for today. Once again, at this point, there are no technical issues that stand in the way of today's launch. And we're going to take a look at the crew suiting up, preparing for today's launch of Discovery on STS-133. Once again, they're in the operations and checkout building here at Kennedy Space Center. And we're seeing Commander Steve Lindsey with one of the suit technicians assisting him into his ACES suit, or his launch and entry suit. Pilot Eric Bowe. He flew on STS-126. He is our pilot today. He's logged over 4,000 hours in 45 different aircraft. This is Alvin Drew, Mission Specialist 1. He's a colonel in the Air Force. Once again, we have an all-veteran crew. Alvin Drew flew on STS-118. He'll be one of our 2 spacewalkers on the mission. Panning around to the other side of the room, Mike Barrett, Mission Specialist number 3. He's a veteran of expeditions 19 and 20 aboard the International Space Station. He spent 197 days aboard the space station and performed 2 spacewalks while he was there. Kennedy Space Center native Nicole Stott, who worked here processing shuttles for many years before becoming an astronaut. She's Mission Specialist 4, hometown of Clearwater, Florida. She flew 87 days on the International Space Station on expeditions 20 and 21, and also performed a spacewalk of 6 hours and 39 minutes. Excited to go into space today. And the newest member of the STS-133 crew, Steve Bowen, who replaced Tim Kopra after the unfortunate bicycle accident sidelined Tim Kopra. Steve is Mission Specialist 2. He logged 27 days in space with 5 spacewalks. He's a spaceflight veteran. And there we see Peggy Whitson, Jerry Ross, a number of other members of the NASA family helping to prepare today's astronaut crew for their mission to space. T-minus 3 hours in holding, 17 minutes to go in our hold. This is Shuttle Launch Control. This is Shuttle Launch Control at T-minus 3 hours and holding. 14 minutes to go in this hold. At this point, everything is go on today's launch attempt for Space Shuttle Discovery on STS-133. The final inspection team, as you can see, is at the 0 level on the mobile launcher platform. So far, they've reported no findings, no major issues, nothing that, that they have detected that they've reported that could be a concern to us. The flight crew has received its weather briefing and is in the process of donning its orange launch and entry suits. The White Room is set up. Weather is cooperating. And before the astronauts walk out of their crew quarters and head to the Astrovan, we wanted to tell you about the STS-133 mission patch. It's based upon sketches from the late artist Robert McCall. They were his final creations of his long and prodigious career. In the foreground on the patch, a solitary orbiter ascends into a dark blue sky above a roiling fiery plume. A spray of stars surrounds the orbiter, and a top-lit crescent forms the background behind the ascent. The mission number STS-133, as you can see, is emblazoned on the patch center, and the crew members' names are listed on a sky blue border around the scene. Space Shuttle Discovery is depicted ascending on a plume of flame as if it were just beginning a mission. However, it is only the shuttle orbiter without the solid rocket boosters or an external tank, as it would be at mission's end, which is signifying Discovery's completion of its operational life and the beginning of its new role as a symbol of NASA's and the nation's proud legacy in human spaceflight. Once again, the patch for shuttle mission STS-133. Again, we're working no technical issues at this time. There's some clouds in the area, but nothing of any significance. We remain 90% go for weather. Everything on target for a launch attempt today at 4:50 and 27 seconds p.m. Eastern Standard Time. This is Shuttle Launch Control. This is Shuttle Launch Control with just under 8 minutes remaining in our hold at T-minus 3 hours. And all continues to go well with Discovery at Launch Pad 39A here at Kennedy Space Center in Florida. The external tank earlier was fueled with 500,000 gallons of cryogenic propellants. And the final inspection team is in the process of wrapping up its final survey of the pad and the various shuttle components, ensuring their readiness for flight. They've been making inspections of the external tank and measuring the external temperatures of the vehicle. We have an array of devices to help them detect anything abnormal, and so far nothing has been reported abnormal. The external tank, of course, has been the subject of a lot of attention over the last several months as we've made some modifications to the stringers on the inner tank, strengthening them and making the repairs that were necessary after we had our launch scrub back in November of last year. The external tank is the largest element of the shuttle system, which also includes the shuttle orbiter and the main engines and solid rocket boosters. The tank is 154 feet tall, 27.6 feet wide. And once again, it's the only shuttle component that is not reused. Once it's filled up with the super cold cryogenic propellants, and depending upon atmospheric conditions, that's when it's possible that we could get condensation and ice forming on the tank surface, and that's part of the final inspection team members' job, to look for anything that, any frost or ice buildup that does not belong. Anything like that could break away from the tank and impact the shuttle's thermal protection system, which is critical for safe re-entry operations, and that's why the final inspection team members are diligent and very thorough in their inspection and in their reporting back to the Launch Control Center. Once they're finished with their work, they will report their findings here to Launch Director Mike Leinbach and to the mission management team members who will be assembling here in the firing room in about 30 minutes. The two solid rocket booster recovery ships, Freedom Star and Liberty Star, left port on Wednesday at about 4:40 in the afternoon and have made their way to the solid rocket booster recovery area, which is about 140 miles northeast of Kennedy Space Center, offshore in the Atlantic Ocean. Those ships are now performing an electrical search of the impact area to make sure that the area is clear of all non-authorized vessels. And about 30 minutes before launch, Freedom Star and Liberty Star will be located about 7 miles from the predicted impact points of the solid rocket boosters. The SRBs are jettisoned about 2 minutes after liftoff, and it takes about 7 minutes for them to parachute down to the surface of the ocean. Once again, everything continues to go well and as planned. We're working no major technical issues. Weather is go. We have about 4 minutes, 20 seconds remaining in our hold, and this is Shuttle Launch Control. This is shuttle launch control at T-minus 3 hours and holding, and about 90 seconds remain in our hold. We're also about 5 minutes away from the STS-133 flight crew making its way out of the operations and checkout building and beginning its ride to the pad. And we will be joined shortly by astronaut Dr. Andy Thomas, a veteran of 4 space shuttle missions and 1 long-duration stay aboard the Russian Mir space station. He'll be joining us shortly. Dr. Thomas joined the Astronaut Corps in 1992, supported launch and landing operations as an astronaut support person, the job that Kay Hire has today, and then also provided technical support to the Space Shuttle main engine project, the solid rocket motor project, the external tank project at Marshall Space Flight Center. And in June 95, he was named as payload commander for the STS-177 or STS-77 mission. He flew his first flight then on Endeavour in May of 96. In January of 98, he launched aboard Endeavour on STS-89 to the Mir space station, where he served as board engineer 2 for 130 days, and returned to Earth with the crew of STS-91 aboard Space Shuttle Discovery in June of 1998. From 2001 to 2003, he was the Deputy Chief of the Astronaut Office and completed his 4th flight aboard Discovery on STS-114 in July 2005, the return to flight mission. And we're about to come out of our hold. 2, 1, T-minus 3 hours and counting.